Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Fighting the Cyber Adversary by Securing Your Software Supply Chain with special guest Eric Greenwald, General Counsel of Finite State. Eric, welcome to the show.
Thanks so much for having me.
Eric Greenwald is General Counsel of Finite State, and we just talked a couple of weeks ago for the first time. I was very fascinated about your background and Finite State and what they're doing. So, Eric, tell my audience a little bit about yourself.
Well, for the last 7 years or so, I've been working in the private sector as a lawyer for cybersecurity companies, focusing on security testing and identifying vulnerabilities. Right now, the work I'm doing with Finite State, Finite State is a company that focuses on embedded software, mostly in industrial IoT devices, but also, medical devices, automobiles, consumer electronics, trying to help identify vulnerabilities that exist in the firmware, most often with software that's been brought into the code through third parties that may already have existing vulnerabilities that people didn't even know existed when they folded it into their device. But prior to that, I was working in government, focusing on cybersecurity and national security. I've spent time working as a lawyer for FBI, for CIA. I spent about 5 years on Capitol Hill as the chief counsel for the House Intelligence Committee. And then after that, I actually went back into the executive branch. I was working at Cyber Command as the deputy director for operations there, and then at FBI's National Cyber Investigative Joint Task Force, where I was the principal deputy director. And then my last government job was at the White House, where I was senior director for cybersecurity on the National Security Council staff.
All right, so you've seen some pretty scary stuff then. Let's just say
some pretty scary stuff. Yes,
yeah. I mean, you're right at the tip of the spear there.
Yeah.
So, I mean, why do you think we're seeing such a emphasis now on secure supply chain, where we really haven't before, and specifically software secure supply chain? Why do you think that is? Why is that such a hot topic right now?
I think it's a little bit is that the threat has evolved. But I want to emphasize a little bit, and I'll get to what else is going on. I think, I think that the increasingly complex nature of software, the fact that software is composed of so many different elements that are from so many different software designers from open source code, and the fact that so many of those components have vulnerabilities, sometimes when they're first created and other times discovered over time, is making it more difficult to secure devices that are built through that software supply chain. I think that what's also happening, and maybe a larger part of why we're seeing this recent emphasis on supply chain cybersecurity, is we've seen some recent attacks. SolarWinds is certainly the best example, where the supply chain was used to affect a really dangerous and impactful attack, affecting a lot of different systems in a way that was not observed for a good long period of time. And people are waking up. It's a combination of people are waking up and actors are becoming more sophisticated about the ways that they are exploiting the supply chain. But a lot of what we're seeing is not new exactly. It's just that people are becoming more aware of the danger.
Yeah, I think the news helps with that, right? I mean, when you see it on the news, also, I've noticed the patience of the attackers the SolarWinds attack was a very patient, well thought out attack. It wasn't like, oh, I got in and caused havoc. It was, I got in and sat on it for a year and a half.
And that is probably the most significant difference between an attack that a nation state might carry out as opposed to a criminal. Criminal organizations have demonstrated pretty decent patience themselves in a number of sophisticated attacks, but they don't have anywhere near the same kind of patience as nation states, where they're not looking, strictly speaking, for a return on investment or financial return on investment.
Right.
They're looking for an intelligence gain, and their masters are patient and willing to let them take years to
Wow.
develop their intelligence access, and then once they obtain the access, to cultivate the intelligence sources, the information that they're looking for. And they're well resourced, both in terms of the money and expertise. But yeah, there's no question that when you have an attacker who is patient, who is well resourced, who is sophisticated, they are much better positioned to take devastating advantage of supply chain complexity, as we saw with the SolarWinds attack.
So what kinds of regulations are coming up, or that companies need to be concerned about, or how do they manage? Because obviously we've got to do a better job as an industry, and there are some regulations that have come out, or some executive orders and things.
Yeah.
So what should, if I'm a software developer, or I have a product out there, where should I be looking, and what should I focus on?
Yeah, so there's a lot out there. There's a lot that's going on. I think where it's probably easiest to focus attention is on Executive Order 14028, which the Biden administration put forward almost exactly, I guess a little bit over a year ago. I think it was May 12th of last year. There's a lot in that executive order, but I can sort of distill the focus into two main points. One is secure software development, and there's a lot of work that's being done to try to come up with technical recommendations for how companies, and to be clear, the executive order is directed only at government procurement. So it's only software companies that are selling to the government, but I'll talk a bit more about that in a moment. Where companies that are building software products for the government can implement secure software practices to try to make their products that they're selling to the government more secure from day one. There is a component of that that's worth singling out, and that is the software bill of materials. And this is something that has been around for a number of years. I think the first draft legislation proposing the software bill of materials, or SBOM, as a requirement came out in 2014, and it's been getting more attention over time. And the standards for producing SBOMs have become more mature, more developed, and we're starting to see greater adoption of the SBOM outside of the government regulatory space. But EO 1428 specifically would require suppliers to government of software products to have an SBOM for the software that they're selling. Now, the exact scope is a technical question that they're still working out, and it's supposed to expand over time. But the general idea is that there would be a requirement for an SBOM. So let me say a quick word about the SBOM, and then a little bit about what's happening more broadly with that goes well beyond the scope of Executive Order 14028. What the SBOM does is it's essentially a list of ingredients for a software product, not completely different from the way you see a list of ingredients on food products. But in this case, instead of wheat and soy and what color dye goes into it, you're looking at the software components. And this goes back to the comment I was making earlier about the complexity of the supply chain, and the fact that for any given software product, you've got all these different software components that the manufacturer didn't write, that they've borrowed or licensed from other sources, including open source. And the software bill of materials would force the manufacturer of the device to list all of those different components. And the reason why this is really important is, number one, provide some transparency into the supply chain, so that when I buy a software product, I can look at the SBOM and say, here are all the different software components that I'm buying when I integrate, or that I'm bringing into my network when I integrate this software, this device, into my stack.
Now, wait just a second there. Why is that important?
For precisely the reason I was stating earlier, that whenever a developer, open source or proprietary, puts together a code, or a set of code or a library, there may be vulnerabilities associated with that. And again, they may be vulnerabilities that are there day one, or vulnerabilities that are discovered later. So that if, for example, Log4j is
I was
probably
going to bring up,
yeah,
Log4j. Everyone used it. Major
yeah,
vulnerability.
yes. But most people didn't know whether they had it in their components, in their stack at all, much less in which components. And this is where an SBOM is particularly valuable. So if Log4j happened in a world where SBOMs were regularly produced and provided to consumers of software and code, software and hardware, then the owner of the devices of the code would have been able, when the Log4j vulnerability was revealed, would have been able to look at their SBOM inventory and say, do I have Log4j as a component of any device or a piece of my network? And I don't want to say that it would have been like waving a magic wand, but it
would have been a lot easier though, right?
It would have made it a lot easier for companies to discover, do I even have Log4j anywhere in my system? And if I do, where do I need to go to implement a patch or to isolate the system so that it's not vulnerable to an attack while I wait for an effective patch? So that is an excellent demonstration of why SBOMs are very important. You have these complex supply chains, you have all these different components, you have limited awareness by the owners of those devices, of the software, whether any particular component is present in what they've acquired. So when you learn of a new vulnerability, the mere act of trying to figure out whether that vulnerability affects your system, and if so, where, is very, very challenging. And if we do see wide adoption of SBOMs, that will become less challenging. I don't want to pretend that it will become easy suddenly.
No, I've heard people. I'm working in a standards group right now that's talking about SBOMs and things like that. And there was a really good argument that came up. If I'm publishing my SBOMs, aren't I just publishing where my vulnerabilities potentially are?
Yeah, and there definitely there's some people who are concerned about providing a roadmap to attackers, and others who are concerned about providing proprietary information. That the SBOM contains secret sauce that they don't want to reveal. I think for the most part the SBOM is at a level of detail where it's not really going to provide that kind of proprietary information. But I think that's a debate and discussion that needs to be had among a lot of different stakeholders to figure out, okay, what is this a genuine concern? How can we mitigate it? The roadmap for attackers, I'm a little bit more clear on. And is there a concern that attackers may know is present in software and code that is used in automobiles, but they might not know, okay, which cars have this? And if they go to an SBOM library, they might be able to say, oh, it's in Audis, it's in VWs, it's in Fords, and focus their attack more narrowly. I think that's a legitimate concern. But what the Commerce Department and DHS have been saying is that there's much greater benefit to defenders in having that transparency than there is advantage given to attackers by having the roadmap that an SBOM would provide.
Yeah, I agree with you there too. But those debates will go on, and in the private sector, you're going to see, well, maybe I don't want to do that, but maybe we have special spices, right, on the ingredients.
Yes.
I don't know what else to do, but we've even talked about maybe if I'm consuming software from someone else, I could set up a secure contract with them, and the SBOM would be in that contract. Yeah. So only I could see, because I am buying that, then only I could see what version they have, and so there could be ways to protect myself more readily. But
yeah, and this is, I think, it's a misconception that opponents of SBOMs have, and that is that, oh, if you're being required to make an SBOM, you're being required to publish an SBOM. And while that's not true, right? There are people who advocate having publicly available libraries of SBOMs. That is not where we are likely to end up. I would say we're not going to end up there. And yes, it is the makers of devices are going to be able to exert some control over who is able to access their SBOM. Now, the reality is once you create an SBOM and you disseminate it to some people, whether it's the people who own your devices or who are looking to buy your devices, you start to lose your ability to exert total control. And so there's a greater risk that will make it out into the hands of malicious actors.
Well, I was actually thinking about that. And we've got technology to create non-fungible contracts. So they can't be copied. And that would be a really interesting way to go.
Yeah.
Right. I mean, no one's going to sit there and read these SBOMs. We already know that, right?
Yeah.
They're going to be machine read. They're going to be checked against vulnerability scans and things like that. So
it's absolutely true. There are ways to try to reduce the risk that SBOMs will fall into the wrong hands. But there's another important point to be aware of, and that is the SBOM for any software or device that is available in the marketplace. The SBOM is information that anybody who has the time and the tools to unpack and reverse engineer that device, that code, is capable of producing. It would take them some time, it would take them some effort, and certainly if they have thousands of SBOMs in front of them and they want to just go find, okay, which one has this particular piece of software with this vulnerability, that's easier for them. But for any individual device or set of code, it is possible for an attacker to take that, do the reverse engineering, and generate the exact same information that would otherwise be available in an SBOM.
Yeah, no, I hear you. So yeah, it's an interesting argument. You said there were two things. The first was SBOMs. What's the next?
Oh, so the first one was secure software development, and the second, which is sort of a subcomponent, is SBOM. But I did mention that I was going to talk about how SBOMs are becoming a force to be reckoned with, even outside of the scope of the executive order, because, as I said, the executive order is limited to in its application to government procurement of software. But as I also mentioned, the SBOM concept is something that's been in existence and development for a number of years, and there are a number of companies that already use it. What you're starting to see is a greater awareness of the existence of SBOM and the utility of having an SBOM in providing transparency into supply chain security considerations. And so we're starting to see wider adoption of SBOM as a requirement in the procurement process, in the private sector procurement process. Show me an SBOM. I want to see the SBOM before I buy this product. Or I want to be able to have an SBOM once I've purchased this product. So I think that you're starting to see private companies, adopt and expand the concept of the SBOM in ways that are completely independent of what's happening in the government. Now, I think that as you start to see the government adopt lean more in the direction of requiring SBOMs, that's only going to accelerate the adoption of SBOM among private sector parties. And it's worth noting that there's now 3 different pieces of legislation on Capitol Hill draft that would require medical device manufacturers to produce SBOMs, as part of the FDA approval process. It's draft legislation. No idea whether it's actually going to make it into law, but the fact that you're starting to see, including, I mentioned 3 pieces, 2 of them, one is a House and companion Senate bills, both of which are bipartisan draft bills. So the fact that you are seeing bipartisan, bicameral legislation that would, if adopted, require medical device manufacturers to provide SBOMs for their devices is a clear indication of the direction in which we're going. How fast we get there, or go in that direction, a separate question. But and whether the private sector just pushes itself there first, before Congress passes a law.
Well, that would be best, right? I mean,
Yeah,
it's best if the industry does it right instead of
agreed. Agreed.
Congress. And granted, Congress is trying their best, but they really don't understand the complexity of the situation.
That's right. That's right. It's also worth noting that part of the reason why we're seeing those bills on Capitol Hill is because the FDA itself has issued some recommendations for medical device manufacturers, suggesting that they incorporate SBOMs as part of their part of the review process for medical device approval. And if the FDA is recommending that, then I think that it's the medical device manufacturing community, I think, recognizes, well, we probably shouldn't show up for a review of a medical device without
one. Yeah, exactly.
So even though it's not required. I think that this is something that is gaining momentum. The SBOM is gaining momentum. The transparency, the importance of transparency, is gaining recognition as a critical part of supply chain cybersecurity.
All right, so this is really interesting, and it's a sweet spot for finite state, right?
Yes,
we're starting to see the physical world being affected by software in a big way. Medical devices, other embedded systems like control systems for power plants, HVAC systems. I was on a conference call with Pearson Airport in Toronto, and it blew my mind what he has to deal with as far as embedded systems, controlling the lights, the baggage, the all this stuff. So to me, this is probably the most critical aspect. I mean, so what if my email doesn't work? But it's a whole different story if I'm stuck in an elevator.
Yeah, you're absolutely right. And actually, the Colonial Pipeline attack provides an interesting
that's a good
way to look at it. The Colonial Pipeline attack itself was on Colonial Pipeline's business systems, not on their operational systems. But because they were, number one, worried about the possibility that the attack had filtered over to their operational systems, and number two, because since their business systems were offline, they couldn't keep track of the flow of gas and actually bill people. They shut their entire operational system down while they stopped to figure out what they needed to do. So the point is, hey, yes, you attack the business system, that's one thing. The operational system is another thing entirely, has much greater consequences, even though the two are interconnected and an attack on one can affect the other. But I take your point, and I couldn't agree more that when you start talking about those operational systems and the vulnerabilities that exist within them, the fact that far too many of them are directly connected to the internet or don't have appropriate firewalls segregating traffic that would provide greater protection. The worry when you think about the complexity of the supply chain, the fact that so many of these industrial operational components are much, much older and have not necessarily been updated, because updating an operational system can either require that you take it offline or runs the risk that you're actually going to break something in the process of trying to update it, that people are very reluctant to do that.
A lot of the OT systems, the operational technology systems, right? They don't want to connect to the internet because, hey, that's how hackers get in. So this is almost a double-edged sword. I've got very old software that might have vulnerabilities in it that could trigger based off of time. I mean, you don't only have to be connected.
Right.
They could have put something in there that, hey, on this day, on this time, this piece of software implodes and brings everything down. You don't even have to be connected to the internet for that attack to happen.
Right.
So there's this quandary, right, for a lot of OT professionals. What do? I don't want to connect it to the internet to get auto updates, because that's scarier than crazy. Yeah. So what do you do? I mean, give me some help. I need help. Help me.
Well, I think probably what is the best thing to do is to try to gain that transparency into the components that are in your stack, to scan the system, scan the devices that are part of your OT network, and do some reverse engineering, decompiling that gives you the ability to understand what components you've got in there, essentially creating your own SBOM, and then being able to assess for those various components. Are there vulnerabilities that need to be addressed that have not been addressed? And are there, for example, hard coded credentials in the system? It's startling how frequently it happens that you have developer of a software product is setting up some very nice and tidy encryption to protect the system, but then leaves in the code hard-coded credentials that enable anybody who can decompile code.
I'm a programmer. I do that all the time.
Yeah.
I need a backdoor. I need a backdoor in there to fix things, right? Because they're always calling me and saying, "Hey, can you, get into the system and fix it, please?" And so you leave that open. I mean, this is a common problem. It's not malicious per se, but
So this is the primary area of work for finite state.
Gotcha.
Is looking at these systems, looking at the devices, doing an analysis. We have a platform that automates the analysis of the code, embedded code, and provides a readout of the vulnerabilities that are present in the system, and also does a complicated job of trying to identify the highest priority vulnerabilities, because you can have an analysis of a device come back with thousands of vulnerabilities, but there are ways to group them, there are ways to rank them according to risk, according to impact, according to how easy it is to knock out a whole category of vulnerabilities with a single fix, and to help the security folks, security teams make their job a lot easier as they try to address the vulnerabilities that they discover in the systems.
Okay, so having an SBOM like that by itself is not good enough, is what I just heard. I need to tie it into a risk management system, because as you said, I can imagine the vulnerabilities they find, right? It's going to find tons of vulnerabilities. So we got to figure that out, right? So that's where risk mitigation and saying, hey, what's the risk of this happening, the impact, all those aspects of a normal risk management system have a big role in this as well.
That's right. Yeah, as cybersecurity services have improved, we've developed an acute signal to noise ratio problem, because when you pick up any system and look at the vulnerabilities, you can find so many different ways that an attacker can exploit it, and figuring out which ones are actually the highest priority is a complicated process, and so that's something that in addition to trying to divine what vulnerabilities are present, Finite State is also working to try to help those security teams do their risk assessment and prioritize the actions that they need to take first with respect to protecting their systems.
Eric, this has been very informative today. A little bit scary. I'm not going to say that it wasn't. But anytime I talk to you guys, you security guys, I'm always like, oh, I got to lock down my home network better. I got to do all this stuff to protect myself.
The way I would put it is, if you're having a conversation about cybersecurity and you're not at least a little bit scared, you're not really paying attention.
I love it. Hey, Eric, thanks for coming on the show today.
You bet. Thank you so much for having me. It's been great.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.